Assalamu alaikum students. Today the topic is for equipotential surfaces. In equipotential surfaces, just what it name declares, a surface on which all points have the same electric potential. Look, equi word is used for equal, same. Potential is potential, and surfaces are the surface at which all the points have the same potential. So this is something like the equipotential surface is actually the locus, the center, the source of all points with the same potential. It might have different configuration, like due to an isolated point charge, positive charge. Look here, this is a isolated point positive charge placed over here, and it has some potential around itself, and this potential is very uniform. The electric field is very uniform, so all the points over here, they will have the same potential. So these circular lines and all the points over that circular lines will have the same potential. So this is in equipotential system. Here in this case, it is also the example of equipotential surfaces, but the geometry is now planar. So this is like V1, V2, V3, and all the three potentials are very same, but the shape is the planar shape. So we may call this type of equipotential surfaces as plane equipotential surfaces. Here we are having the 2 point charges but opposite. One is positive, another is negative, and you must know the direction for positive and negative. We have studied this example before when we were discussing the electric field. So this is actually the point, this is actually the line at which all these points have the same potential between positive and negative charge. So you can say this is the equipotential line at which all the points are having the same potential. Now there are some important terms related with equipotential surface, such as equipotential point, equipotential line, equipotential surface, and equipotential volume. And the names are very clear. Look, if there are points with the same potential, it would be known as equipotential points. So means the points in any electric field, if they are all at the same electric potential, they are called equipotential points. And if these points are connected by a line or curve, it will be known as equipotential line. Equipotential surface का तो आपको पहले ही पता चल गया है, the surface in which all the points are at the same potential, so that would be equipotential surface. And if all these points are distributed throughout a space or volume and they have the same potential, so that would be known as equipotential volume. Now we are going to calculate the work done in equipotential surface, a very important concept connected with the equipotential surfaces. As you have defined the work done before, as that is the work done is due to the change in potential. When you move a charge from one potential to another, suppose one of the potential is VA and another potential is VB. Consider these 2 points like A and B, and a charge is moved either from point A to B or from B to A, then it would have some sort of change in potential, and that change in potential is appeared as work done. But the work done in moving a charge between 2 points in an equipotential surface is 0, because both the points would have the same potential. VA and VB both are same, so there is no difference. This term goes to 0. So if a point charge is moved from point VA, this is VA, to VB, then the work done in moving that charge is 0. So look, VA minus VB is equal to 0. So the total work done inside an equipotential surface is always 0. Don't forget this term. This is important for usually the short question. It is involved in exam. So you must know if you are asked about what is the work done in equipotential surface. So that is 0, and you can prove it mathematically, like the potential difference between 2 points for which the charge is to be moved, that is actually 0. So the work done is 0. Now there are some important properties of equipotential surfaces. So you must know about those properties as well. One of the property is the electric field direction. As you know, electric field is a vector quantity. So the direction of the electric field is always perpendicular to the equipotential surface. No matter what the geometry, what the shape of the equipotential surface is, but electric field is always perpendicular to that equipotential surface. And if there are two equipotential surfaces in a system, they will never intersect each other. So this is the second property. The third property is the direction of the equipotential surface is always from higher to lower potential, and this is very natural. You know that all the quantities, whether that is for potential, the energy, the heat, the natural tendency of the quantities are always from higher concentration to low concentration. Another important property which you have proved earlier, that is no work is required to move a charge from one point to another inside the equipotential surface, because they are at the same potential. Work is actually due to a change in position, a change in energy, a change in potential. But in equipotential surface there is no change in potential, so no work is required. Another one is for an isolated point charge, the equipotential is in a spherical form. And the last one, but very important, it is the spacing between equipotential surfaces tells us about the strength of the electric field. Because look, you have studied this formula before for the electric field as potential gradient. So in this formula you can see that the electric field is inversely proportional to the distance. So if the distance is very small between the equipotential surfaces, the electric field strength will be maximum over there. So this is all about the equipotential surfaces. You can define equipotential surface. You can draw it for various charges. A single positive charge for planar charge distribution, for the combination of two positive and negative charge. You can calculate the work done for equipotential surfaces. You can define the important related terms with the equipotential surfaces, and you also learn about the important properties of the equipotential surface. Thank you.